Hey, welcome back to our video. Let's continue discussing about allowable tensile stress. So we were disconnected somewhere, but let me tell you that we have to consider the following. So this one is actually in terms of the stress, but the symbol is F. Tensile stress, but the symbol is F. Okay? The unit of stress is MPa, as I mentioned a while ago. MPa. So MPa is the unit of pressure or stress. Okay? But the symbol is F. Okay? And if you multiply that one by area, so the unit of stress MPa multiplied by square millimeter, what will remain is Newton or kilonewton or something Newton. Okay? So Newton is a what? Is a unit of force. But take a look. It is T as in tension. This is actually tension force. And this is pressure. So letter F. Okay, letter F. So do not interpret this as force. This is stress. This is stress or pressure. This is T. This is force. So that's why in civil engineering, they started to mix up the symbols. Instead of properly using F to represent force, they use T to represent force, and they use F to represent pressure. Okay, so take note of that. Okay, this is stress, capital F. This is tension force, which is T. Okay, okay, let us continue. So we already discussed and talked about actual effective net area, wherein we have a reduction coefficient multiplied by the net area. We have what actual effective net area. Then for pin connected members, so for pin connected members, we have letter A, tension. Okay. So tension here is, this is actually stress, FT. Same is true with this, okay, FT. Okay, in terms of MPa is equal to 0.45 Fy. Okay, so a while ago it is 0.6 Fy. Now it is now 0.45 Fy. Okay, that is for pin connected members on the net area of pinhole. Okay, take note, net area of pinhole. Okay, note of that. We will have an example. We'll have an example of this. So bearing stress, letter B, on the projected area of pin. What is the formula? FP. Okay. The meaning of FP is bearing stress. Okay. So something is really bad about civil engineers, no? Instead of using FB, which means bearing, so FP, which means bearing. P, okay, letter P, okay, as in Papa, okay, FP is equal to 0.9 Fy, right? So when we are using bearing, so when we are going to solve bearing stress, that is 0.9 of Fy. Okay? And if you would like to know the bearing stress for expansion rollers and rockers, okay? Ruler, okay? Ruler meaning it is a what? Circular member, okay? A rocker. So FP, which is the symbol for bearing stress, is equal to quantity numerator of Fy minus 89.6 divide by 137.8, multiply by 0.66 D. We already know what is Fy. What about D? Small letter D. Small letter D is diameter of ruler in millimeter. So if that is correct, the unit of bearing stress is Newton per millimeter. Okay? However, the unit of measure is Newton per square millimeter. Newton per square millimeter. And so on. Everybody is Newton per square millimeter. Only this one, Newton per millimeter. There is no square. Take note, take note. Okay? Okay, so let us proceed further. Okay. Another major topic, net areas. What do we need to know about net areas? These are areas wherein the gross areas have to be subtracted by what? By the whole diameter and notch dimension. Notch dimension and whole diameter. So subtract those things from the gross area, then you have net area. Okay? So let us have an example. Example 001. Find the diameter of hole. Okay? What are the given? Diameter of bolt given is 20 mm. What are other given? So another given, standard. When we talk of diameter of bolt, that is what? That is nominal. This is what we call nominal diameter, 20 mm. Okay? What about the standard diameter? If that is the nominal, we have standard diameter of that diameter of 20 mm is actually equal to what? 21 is the standard diameter. Anyway, these are what? These values are actually tabulated in the code. In the code, NSCP or what? Or the AISC. What do you mean by AISC? American Institute of Steel Construction, or NSCP, which is what? The Filipino version or the standard in our country. Okay. So standard diameter of this 20 mm is actually equal to 21 mm. Okay. And what about diameter of hole? Diameter of hole. Okay, diameter of hole. If we have 20, then standard diameter is 21. What is diameter of hole? Diameter of hole is 21 plus 1.6. These are in terms of mm. So therefore, we can find the diameter of hole if this is given. This is given. Diameter of bolt is given. You can find the diameter of bolt, which is equal to 21 plus 1.6. That is 22.6. So you can just what? In actual, you can just plus 3 mm. Okay. So or to be exact, 2.6 mm. Okay. That is diameter of bolt. Okay, so that is what? This equation. So diameter of hole plus net area, we have gross area. Okay. Okay. So gross projected area. Okay. Projection. Sir, we are just using mm. That is not the unit of area. Of course, that is not a unit of area because all of the thickness are the same. That's why we are just comparing the length of or the diameter, because the thickness is the same for everyone. The thickness is the same for hole, thickness is the same for bolt, and so on, for the plate and so on. So the thickness are the same. That's why. So if you really need to find out the area, so you have to multiply this by thickness. Okay. Take note of that. Okay. So let us continue our next example. So I will just post the video and write down the next sample. So we have to take another example. Sample number 2. Find the net area of the 100, actually 10 mm by, this is a typo error. This is 10 mm by 200 mm plate for the butt joint connection. What is a butt joint connection? This is how we connect it using butt joint. If the diameter of the bolt is 20 mm, so this bolt, there are three rows of 20 mm bolt. So one row, second row, third row. They are all 20 mm bolts. So the other plate is 6 mm thick. This one and this one, both 6 mm. The center plate is 10 mm. So we are actually being asked for the center one, not on the 6 mm plate, because this is 10. We are being asked find the net area of this one. Okay, so that is the question. Okay, so let us compute for the net area. Okay, for the net area, we'll have what? Solution. Okay. So what is dn nominal or hole diameter? Nominal hole diameter, which is nominal hole dimension, hole diameter, hole diameter. Okay. So plus, we always add 1.6. Remember the first example, 1.6. So 1.6 is added. That is for 20 mm bolt. So sometimes we need to memorize those constant. Okay. That is for 20 mm bolt. You have to add 1.6 mm. The previous example, also 20 mm bolt, we add 1.6. Okay. So if so we already know about this, okay, from the previous example, which is the nominal is actually become 21, so 20 plus 1 plus 1.6. We already know this from the previous example. This is what? This is the standard. This is the nominal, this is the standard. Okay, plus 1.6, this is actually 22.6 mm. Okay, so therefore, our net area, when you are looking for the net area, so it's equal to what? 200. Okay, the length is 200 mm. Minus what? So So you can see, we have what? From this point to this point, this is 200. Like this, 200. 200 minus 2 times dn or dh. Okay? 2. So this is 22.6. So times 2 of that. So minus 2 times 22.6. That is what? 45.2. 45.2 minus that, okay, value. Then multiply by thickness. The thickness is 10. So therefore, this is the time we need to multiply by thickness. Okay, so we have what? 200 minus 45.2 times 10. Okay, the thickness is 10. So how much is that? 154.8. No? 100. Therefore, we have the answer 154.8. So times 10, 1,548. Okay? So this is what in terms of mm squared. Now, this is the net area. This is the net area. So, this is the net area. We can compare this to what? AN compared to 0.85 AG. So compare it. Is it okay or not? What is AG? So we can what? We can solve for AG, which is this one. This part is 0.85. What is AG? 200 times 10. 200 times 10. This is 2,000 times 0.85. So 0.85 times 2 is, that is 1617. 17 mm squared. So therefore, 1548 is less than this one. Okay? Okay. So this is our answer. That's done. Okay. So what is this?